Welcome to the section of this course. Today we are going to speak about integral of exponential functions. Okay, here I have written some few questions. There are 7 questions. Okay, these are simple exponential functions. Let's try to integrate this. Now, first one is what? Integral of e raised to 1 plus 3x dx. Okay, this type of integrations we can solve in two ways. Okay, here we can substitute 1 plus 3x as a u. Okay, let's put u equals to 1 plus 3x, then du by dx will be, here differentiation of what constant is 0 plus 3x. Okay, here into 3, u by dx of x is 1. Now therefore du will be 3 into dx. We need only dx. Okay, here I can send du by 3, that is dx. Okay, this integral will be 1 e raised to, this will be u, dx is what? Du upon 1 upon 3. I can send this 1 upon 3 outside because it is constant. Okay, now integral of 1 by 3, integral of e raised to u. Okay, integral of e raised to u du is same as e raised to u plus c. Okay, now here you can stop here. Okay, because you already put new variable as u, you already assigned, you have to come back into the x. Okay, so therefore this 1 by 3 into e raised to, what is u? U is 1 upon 1 plus 3x plus c. Okay, this is a required answer. Okay, another way what we can do is, like for example, if I have integral of e raised to x dx, you can consider like this, is equals to e raised to x, integration of e raised to x is e raised to x. Okay, therefore I will keep as it is. Let's consider whole this as a x some variable 1 plus 3x upon, if you differentiate this with respect to x. Okay, this with respect to x is what? 1 plus 3x is what? 3 plus this. This is a direct way. Okay, here also you can solve in that way. Second number is here. Here also we have to substitute e raised to x, or you can solve e raised to x as a variable t, or you can do like this, you can bring up. Okay, let's try this way, 1 upon e raised to x the whole square dx. Okay, this e raised to x the whole square is same as 1 upon e raised to 2x. Okay, I can bring up by using exponential rule, or you can say algebraic rule. It will be e raised to 2x dx. Same as, okay, this is same as integration of e raised to minus 2x. You can put this as a u, or you can directly integrate. Okay, e raised to minus 2x upon differentiate minus 2x respect to x will be minus 2. Okay, here minus 2 plus c. Okay, or you can put minus 2x as u, differentiate it, and you come back the same way it has done. Okay, we can solve directly in this way also. Okay, another way is, another example is this. Okay, in question number 3, x into e raised to 4x square into dx. Now if I substitute 4x square as a u, okay, so I can get differentiation somewhere x into dx. Okay, let's try this. So now here x we have x into e raised to 4x square into dx. Okay, now if I put 4x square as a u, okay, u equals to 4x square, then du upon dx will be what? This 4 is a constant, okay, and the differentiation of x square is what? Twice x, okay. Therefore 4 into 2 is 8x, okay. Therefore du equals to 8x dx. I am sending this that side, okay, here. Now I need only x into dx, so I can send this du upon 8 equals to x into dx, okay. Therefore this it become what? Integral of e raised to what? U into what? Du upon 8 x dx become a du upon 8. This 8 I can send outside because it's a constant. 1 by 8 integral of e raised to u du. We have 1 by 8 in e raised to u du is e raised to u plus some constant. You come back where you have substitute. U is what? 1 by 8. E raised to u is 4x square plus c. This is the answer for this. Okay. Now question number 4. Question number 4, what we can do is we can separate, we can divide, we can separate from this upon this minus this upon this. Okay, let's try in that way. For is we have e raised to 5t minus 1 upon e raised to twice t dt. Now I can separate this upon this minus this upon this. Okay, is same as before integrating. E raised to 5t upon e raised to 2t minus 1 upon e raised to 2t dt. Okay, now just I am separating this. Okay, now e raised to base are same. Okay, e raised to 5t, it will be what? Minus. Okay, minus 2t minus this will come off minus 2t dt. Okay, base are same, we can add the power, or we can since is formula like a raised to m upon a raised to n is a raised to m upon this. I am applying this formula. Okay, e raised to 5t minus 3t is 2t is 3t minus e raised to minus 2t dt. Here I have not done any substitution. Okay, so we can integrate directly. Now integral of e raised to 3t minus integral twice t dt. Okay, here integral of 3t dt is integral of 3t upon 3 upon 3. Why? Because this differential with respect to t minus e raised to minus 2t upon divide dx of minus 2t with respect to t become a minus 2. Okay, here minus 2 plus c, here minus minus plus e raised to 3t upon 3 plus e raised to 2t upon minus 2t upon 2 plus c. Okay, this is the correct answer. Now this is same as this. Okay, now here we have to put x4 as a u, then you will get x cube dx as a x cube dx as in terms of du. Okay, this is same, so I will solve this one. Now question number 6. In question number 6 we have square root of. Okay, here we have integral of e raised to x square root of 1 minus e raised to x dx. Okay, here we have to think what to put. Okay, now here inside the square roots, if I put u square equals to 1 minus e raised to x, then square root and square root gets cancel. Okay, so in that way, or you can say just put u. There will be u raised to half 1 by 2, 1 and 7. Okay, so I'll put u square equals to 1 minus e raised to x. That will be twice differentiate this with respect to here, twice u into du equals to differentiation constant is 0 minus e raised to x into dx. Okay, now here e raised to x into dx, I need e raised to x into dx. Here minus, I can send in that side, 2u du will be e raised to x into dx. Why minus e raised to x? Here differentiation of constant is 0. Okay, u square become twice u du. Okay, now integral e raised to x into dx become a minus 2u du. Okay, so therefore this, what is this? Square root of, this is what? U square into minus 2u du. Okay, square root and square gets cancel, it become a integral u minus 2 I can send outside of integration into this u into du is equals to minus 2 into u into u is become a u square du. Okay, here we have integral of x raised to n is x raised to n plus 1 upon n plus 1. Okay, applying that formula, this become u raised to 2 plus 1, that is 3 upon 3 plus c. Okay, now here you have to come back. Okay, x, here u. Okay, you have to find what is u. Okay, from here what is u? U equals to 1 minus e raised to x raised to half. Okay, if I take square root on both sides, then u square and u square root of u square, then become u, this become a square root. Okay, now I want u cube. Okay, from here I can find cubing on both sides, u cube will be 1 minus e raised to x raised to what? 3 upon 2. Okay, cubing on both sides. So this is minus 2 will be 1 minus e raised to x raised to 3 upon 2 upon 3 plus c. This is the required answer for this. Okay, now for this also we have to substitute 1 upon x square as a u. Okay, question 7, integral e raised to 1 upon x square x cube dx. Now if I substitute u equals to 1 upon x square, that is x raised to minus 2, du will be minus 2 x raised to minus 2 minus 1 will be minus 3 into dx. Okay, now here I am getting this term, therefore du upon minus 2 is x raised to minus 3 dx. Okay, now this term will be what? E raised to 1 upon x square is e raised to u x, this term is du upon 1 by minus 2. I am taking outside 1 by minus 2. Okay, therefore minus 1 by 2 integral of u is integral of u plus c 1 by 2 in u is what? U is e raised to 1 upon x square plus c. Okay, This is the answer for this. Okay, these are a few examples for integral of exponential functions.